The Koopmans theorem, it allows us to connect the Lagrange multipliers arising in the Hartree-Fock equations with some magnitudes that can be experimentally measured. For example, the ionization energy or the electron affinity of an atom or a molecule. For example, let's consider the ionization energy. Let me remind you what's the ionization energy. The first ionization energy is the energy required to remove the most loosely bound electron of an isolated atom or a molecule. Of course, you need to give energy to the system if you want to remove the electron of the atom and have a cation. Therefore, the ionization energy is defined as the energy difference between the final state minus the initial state. The final state, you have the n-1 electron state, and the electron you're removing is an electron in the HOMO state. Let me remind you what's an HOMO state. It's the highest occupied molecular orbital. So when you making that energy difference, considering the Koopmans theorem, is just minus the Lagrange multiplier associated to the HOMO state. And of course, the first ionization energy can be experimentally measured, and you can compare it with the calculations within the Hartree-Fock approximation. Then the other magnitude that it's interesting can be connected actually with the Hartree-Fock calculation is the electron affinity. The electron affinity of an atom or a molecule is the amount of energy released when an electron is added to a neutral atom or molecule. If you add an electron to a system, to a neutral atom or molecule, it might prefer to get that and become an anion and release energy, just in case the anion is more stable than the atom. So therefore, for such systems, you can measure the electron affinity. And again, the electron affinity is going to be the energy difference between the final state, the state where you have n+1 electrons, and the initial state where you have just a system with n electrons. Here, the final state, you are adding 1 electron, and the electron you are adding is going to be in the LUMO state. Let me remind you, what's a LUMO state? Is the lowest unoccupied molecular orbital. So making that energy difference, considering the Koopmans theorem, is basically the Lagrange multiplier associated to the LUMO state. So again, have another magnitude that can be compared with the Hartree-Fock calculations.